Hi guys, Mr. Gillen here, and we're going to talk about in this video the discriminant. Within the quadratic formula, which you might remember from previous videos, we have something called the discriminant. How we represent that, or how it's denoted, is either with a capital D or the symbol delta, which you can see here. During this video, we're going to use this form of the symbol itself. What is the discriminant itself? Well, we can see here that the discriminant is b squared subtract 4ac. Now, if you think back to the quadratic formula, as a reminder, the quadratic formula was x equals minus b plus or subtract the square root of b squared minus 4ac all over 2a. And our discriminant appears underneath the square root sign. So if you are in an exam or a test and you recognise that the question's asking for you to use a discriminant, go to the formula page if you can't remember it, and just remember it is underneath the square root sign. What do we use it for? Well, we use the discriminant to determine the nature of the roots of a parabola. So what do we mean by determine the nature of the roots? Well, if you think back to when you were sketching parabolas, you know that the roots are where the parabola crosses the x-axis. And we've got three individual types of how that can happen. The parabola can cross the x-axis twice, like in the first one. It can cross the x-axis once, like in the second diagram, or it will never come into contact with the x-axis at all, like in the third diagram. And how do we know from our working what one will be what? Well, if b squared minus 4ac, if your answer is greater than 0, then that means the roots are real, they exist, but they are not equal, they're two different numbers. If b squared subtract 4ac is equal to 0, then that means the roots are real and equal, so it's only going to cross the x-axis once. If b squared subtract 4ac is less than 0, then that means there are no real roots. It means that the parabola itself is not going to cross the x-axis. It's not going to touch the x-axis at all. So you might want to pause the video just now so you can copy these three graphs into your notes jotter, and then we'll carry on with some examples. Okay, so let's have a look at some examples. This tends to be the phrasing of a discriminant question. So if you see the phrase determine the nature of the roots, then you're going to be using your knowledge of the discriminant, and that's what the process you're going to be expected to do is going to be. So I've got 4x squared plus 12x plus 9 equals 0, and I've identified that I'm going to be using the discriminant. So the first thing that I'm going to do is write out b squared minus 4ac. Where am I going to get a, b, and c from? Well, we're going to use some transferable knowledge from factorising and from quadratics. I'm going to get a, b, and c from my equation. So a is going to be 4, b is going to be 12, and c is going to be 9. So b squared is going to be 12 squared, subtract 4 times 4 times 9. So that's going to give me 144 subtract 144, which is equal to 0. So from the 3 previous graphs, I know that if b squared subtract 4ac is equal to 0, then there is only one real root. Just like Pythagoras, I'm going to have to actually write a statement at the end of this question. And all we're looking for is as b squared minus 4ac is equal to 0, there is one real root. Okay, not looking for a massive paragraph, we're just looking for b squared minus 4ac, whatever it has, if it's over 0 or equal to 0 or less than 0, and then the appropriate explanation for it. So as b squared minus 4ac is equal to 0 in this case, we know there is going to be one real root. Okay, let's look at the second one then. So same idea again. I've got determine the nature of the roots of this equation. So that's setting off the wee trigger in my head. I know that I'm going to be using the discriminant, and I need to find my values for a, b, and c. So this time a is going to be 1 because I've got x squared, b is going to be 7, and c is going to be negative 2. Remember, we always include the operation in front of the number. So I've got 7 squared, subtract 4 times 1 times negative 2, which is going to be 49. Negative 4 times 1 is negative 4. Negative 4 times negative 2 is positive 8. So this time I'm left with 57. Again, I need to write my statement. So 57 is greater than 0. So as b squared minus 4ac is greater than 0, I know there are two real roots. And the last one, we've got 2x squared subtract 2x plus 5 equals 0. Again, I have identified that I'm going to try and determine the nature of these roots. So I know I'm going to be using my discriminant. And once I've got my values for a, b, and c, again, make sure that if there's negatives, you're including them. I'm going to have negative 2 squared subtract 4 times 2 times 5. Negative 2 squared is 4. Take away, well, that's going to be 40. So this time I'm left with negative 36. For my statement, as b squared minus 4ac is less than 0, there are no real roots. And that's me sorted. Thanks for listening. Speak to you all soon. Mr. Gillen, signing off.